Sure. Okay, good morning, children.
Good morning, sir. Good morning, sir.
Okay, today the topic what we are going to start is about surds. What we are going to start the topic today?
Surds.
Surds. Okay. Okay, before going to the definition of the surds, let us recall those things which we have learned in the previous class. So, what is meant by terminating and recurring? What is meant by terminating and what is meant by recurring? Anyone? Whether you are hearing, you are able to hear me or not?
Yes.
What is meant by terminating?
Terminating decimals have a finite number of digits after the decimal point.
Okay, very good. And terminating means where we are going to get a reminder as zero, whereas recurring means a set of numbers will be repeating again and again. So let us come to the surds here now. Okay, so if you take an example of root of 9, how much you get? What is the result of root of 9?
3, sir.
3. Okay,
3,
if
sir.
you take a result like example root of 25, what is the result you will get? 5.
5, sir.
Okay,
5.
but certain cases are there when you find out the square root of some other numbers, like that is square root of 2. What you will get the result? What is the result?
1.
Huh? When you go on dividing our square root, how much you are going to get? So you are going to get what? Non-terminating and non-recurring decimal expansion, which is nothing but a irrational number. What you are going to get? Irrational number. Before in the earlier classes I have mentioned you that root 2 is nothing but it is a irrational number. Now coming to the point that what is meant by surds. Okay, shall we come to the point now? Start
Yes,
madam
sir.
Ray. Okay, so the condition is if it has to be called as a surd, it should be having a root. What it must have? ಒಂದು ಸರ್ಡ್ ಅನ್ನು ಅನ್ಬೇಕಾದ್ರ ಏನಾಗಿರ್ಲೇಬೇಕ್ರಿ? ಏನಿರ್ಲೇಬೇಕಂತ ಹೇಳಿದೇನ್ರಿ ನಿಮ್ಮ ನಾನು ರೂಟು which should have a root. Okay, so coming to the point, surds. So how you can define the surds? So surds are nothing but a kind of a numbers are nothing but irrational root of a rational number. What is that? Irrational root of rational number. What is that? Okay, now coming to the point that how we can understand this definition, that is irrational root of a rational number. To the right side of your screen, you can observe that we have put it that standard form of that is surd. What is that? Standard form. ಏನು ಹೇಳಿದೆ ನಾನು? Standard form. That standard form can be written as in this way, that is nth root of a. What we can say it as nth root of a. So here nth and a, what are those n and a? You can observe here that n is nothing but a natural number that is greater than 1. You can observe on the right side of your screen. N is nothing but a natural number. A natural number means automatically we have understood that it should be a greater than 1. And this part, that nth root, what we are calling that n represents order. That n has been given the name has order. What we are calling that n has order. No, natural number. Okay, but when you are naming this person, this n is being called as order. And whereas that a is nothing but a positive rational number. That person that is present within the root, that is should be a positive rational number. What it should be? positive rational number. Okay, and suppose if the two conditions are satisfied, then again it should satisfy one more condition, that is the result should be irrational, then only it is being called as a surd. I'm repeating once again that the first case is what we should be a, that what order should be natural number, and that person within the square root, that a is called as radicand. What we call that? ಏನು ಹೇಳ್ತೀವಿ ಅದಕ್ಕೆ? ರೆಡಿಕ್ಯಾಂಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ರೆಡಿಕ್ಯಾಂಡ್ ನಾವು ಏನಿರ್ಬೇಕಪ್ಪ ಅಂದ್ರೆ ಅವ ಪಾಸಿಟಿವ್ ರ್ಯಾಷನಲ್ ನಂಬರ್ ಇರಬೇಕು. ಇಟ್ ಶುಡ್ ಬಿ ಅ ಪಾಸಿಟಿವ್ ರ್ಯಾಷನಲ್ ನಂಬರ್. ಅಗೇನ್ ಒನ್ ಮೋರ್ ಕಂಡೀಷನ್, once that what order is natural number, radicand is again a rational number, again it should satisfy one more condition, that is the result should be irrational number, then only it is a surd. For example, if you take an example, that is square root of 4. If you take an example, for example, can you observe that here order ಅಂದ್ರೆ ಯಾರ್ರಿ? Square root that is present within that square root, above the square root, that if any person is not there, we are considering it as 2. This exponential form can be written as 4 raised to 1 by 2, which you have learned in the earlier classes. Okay, this square root of 4, you can observe that order is 2. Order ಎಷ್ಟದ್ರಲ್ಲಿ? What is the order there? Order means which is present in the square root. Order is 2. Radicand. What is the radicand here? Within the square root. What is the radicand? Radicand is 4. Okay, this is natural number. Yuriaru, natural number. This is a natural number, and this is what? Rational number. So the both the conditions are satisfied or not? Both the conditions satisfies. Condition satisfy ಆಗುತ್ತಾ? But whether the result is rational or irrational, result ಅಂದ್ರ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 4 ಏನ್ ಬರುತ್ತೆ ರೀ? Rational ಬರುತ್ತ. So when you are getting a square root of any number, it means a positive rational number. If it is a rational, then that thing is not being called as a surd. It is not a surd. When it is a surd, if the result is irrational, you are getting my point? ಅರ್ಥ ಆಗತ್ತದ್ರಿ? Why square root of 4 is not been called as a surd means how you can tell that explanation, or else I will repeat it once again. Whether you need to repeat it once again about the surds or its conditions to be called as a surds. Okay, I am going to repeat once again. When you consider the general form of surd, that is nth root of a, here n is the order, a is the radicand. That person above the square root is called as order, within the square root that is radicand. And here when it comes, I have said you that it should obey the three conditions. Which are those three conditions? The first two things are, it should order should be what? Natural number. It should satisfy that it should belong to the natural number, and radicand should belong to the rational number. And one more third condition is, when you take out the square root of such rational number, the result, the result ಏನಾಗಿರ್ಬೇಕಪ್ಪ ಅಂದ್ರೆ that should be irrational number. Suppose the result is rational number, then it is not being called as a surd. This is not a surd. I hope you are getting an idea.
Yes, sir.
Can you explain me that once again, why we are not been calling square root of 4 as a surd? Anyone? It shows that you are not still clear with the points which I have explained now. Whether you need to repeat me once again? Okay, I am repeating it once again. I have told you that the standard form of a surd is nothing but nth root of a. Here n is being called as a given as a name as order, and a is given as a radicand. If it has to be a surd, the three condition it has to follow. I am repeating, it has to follow the three condition. That is condition number 1. Conditions. The first condition is order should belong to the natural number. The second condition is radicand, that is present within the square, that radicand should belong to the rational number. And the third condition is result. It means when you take out the square root of that thing, that should be what? that should be irrational number.
Irrational.
Then if suppose if these three conditions are satisfied, then such thing or such number is being called as surd. Hope at least now you are clear with those three things, or else I will repeat it
Yes,
once
sir.
again. Or
Yes,
Thagitri?
sir. Yes, sir.
Okay, tell me that why square root of 4 is not an surd. Why square root of
Sir,
4?
because that
Huh?
Sir, because that four is not irrational number, sir.
Why? No, you should not tell like that. You should tell that among the three condition it is not obeying the third condition. That is what the third condition, when you take out the square root of 4, the result what you are getting is a rational number, that is 2. So that's why it is not a surd. If the result is irrational, then only it is being called as a surd. Whether you got my point?
Yes, sir. Yes,
Okay,
sir.
anybody?
Yes, sir.
Anyone? Anyone? Yes, anyone? Yes, anyone want to repeat the same thing what I have just told about the conditions to be called as a third?
So, order can be
Hmm.
natural number, sir.
Very good.
And
Ready can?
uh, uh, ready ready can be positive rational number, sir.
Yes.
And result can be irrational number, sir.
Result should be irrational, then only that thing or that number is being called as irrational, sorry, that is surds. Okay, so let us see some examples for surds. So when you observe the examples of surds, we can take it as root of 2. I have already been mentioned that when we have been started to learn about the irrational number, the first irrational number we have learned is root of 2. Whether root of 3 is a irrational number or not? Yes, root 7.
Irrational number.
Root 7.
Yes, irrational. Irrational.
Okay, these all things are nothing but the irrational numbers. Those which are not surds. I am making here one more column. This side's not surds. That is, for example, root of 4, which result is a rational number. Therefore, it is not a surd. Root of 25 and root of 9.
Root of C.
Okay, once one the ನಿಮಿಷ. Okay, that root of 9, root of 16, these all are nothing but these are not being called as asserts. Why? Because their result, it means the value of root 4 is 2, the value of root 25 is 25, and value of root 9 is 3, and the value of root of 16 is 4. These all are what? Rational numbers. Therefore, they are not called as surds. Okay, there is one more saying that whether the all irrational number are surds. Let me see whether you are agree with the statements or not. My statement is all irrationals are all irrationals are surds. Whether it is true or not. What do you say about this
Yes,
statement?
sir.
You agree
True, sir.
that all
Yes, sir.
irrationals are surds, it is wrong. But if you say that all surds are irrationals, then it is true. All surds are irrational, then it becomes true. But when if you say that all the irrationals are surd, it is wrong. Can anybody say that why that statement all irrational numbers are surds is been wrong? Yes, anybody? What might be the reason that that statement all irrationals are surd is wrong, whereas all surds are irrational is true? Anyone can give the reason for that? Already we have discussed in the previous classes when was been telling you about the irrational numbers. I have given few examples are there. Tell me a few more examples of
Sir,
irrational. Yes.
pi, sir.
Huh?
Pi, sir.
Very good, very good.
Pi,
Pi.
sir.
The reason only is pi, e, and I. Okay. You will learn in the higher classes about those things, about e and I, those all things. But up to your consideration, this pi and e are the irrational numbers which are not the surds. So this statement is wrong. What? that all irrationals are surd, but all surds are irrational. That is true. ಎಲ್ಲಾ ಕರ್ಣಿಗಳು ಏನಕ್ಕಪ್ಪ ಅಂದ್ರ ಅಭಾಗಲಬ್ಧ ಸಂಖ್ಯೆಗಳಕ್ಕವ, that we are calling in Kannada. Okay, I hope you are getting the point that all the surds are irrational, but all the irrationals are not surd. ಅರ್ಥ ಆಗೈತ್ರಿ?
Yes, sir.
ಓಕೆ. ಓಕೆ, ಇನ್ನೇಮ್ ಹೇಳ್ತೀನಿ
Yes,
ನೋಡ್ರಪ್ಪ.
sir.
ನಾನು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ಅಂತ ಹೇಳಿದ್ದೆ ನಿಮ್ಮನ್ನ ಆಗಲೇ. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ಆಫ್ ಸರ್ಡ್, just now I have told you that that is nothing but nth root of a. If you write in exponential form, you will get a raised to 1 by n. What you get in exponential form, that is a raised to 1 by n. Okay, this nth root of a, in this part nth root of a, which we call it as a standard form of a surd, you should be clear that a is being called as what we call it as a radicand. What we call it as radicand. Whereas what we call it as n, what we are calling n, order. Order. Okay, so I hope you are clear with those all things. Okay, let me take few examples about being distinguished between order and radicand. Suppose if you have a square root of 2, what is order? What is order here? 2.
Two, sir.
What is radicand? What is radicand? 2.
Two,
Suppose if you
sir.
have an example of 3 root of 2. Yes, what is order?
Three, sir.
Very good,
Three.
very good. Radicand, what is radicand there?
Two, sir.
2, very good. Suppose if you have an example that is fifth root of 3. Yes, what is order here? Order is
Five, sir.
5.
Five.
Radicand is, what is
Three,
radicand
sir.
here? 3. Okay, I hope you are getting those points. ಅರ್ಥ ಆಗತೈತ್ರಿ? Okay.
Yes, sir.
So, after coming to know that what is meant by surds, what is meant by order, what is meant by radicand, yes, somebody is asking the question. Yes, is there any doubts? Okay, okay. After getting to know that what is meant by surd and what is meant by order and radicand, so here we are going to learn about what is meant by like surd. What is the next point we are learning?
Like, sir.
Like
Like.
surds here. Okay, here coming to the point that how to define the like surds. Like means those which are having the order and radicand same. What we are saying that if order and radicand are same, order and radicand are same, then they are called as like surds. For example, if I take, so have the concentration on the screen. So I am going to write, whenever you are telling about like surds means you are comparing to two or more surds. Here I am going to write root of 2 and 2 root of 2 and 3 root of 2. Can you observe that here order of all the three surds is 2? Yes or no?
Yes, sir. Yes, sir.
Okay, now the question comes that the person who is outside the surd, 2 root of 2 is there. So this person is called as coefficient. What we call it as?
Coefficient.
That thing is called as coefficient. What we call it as? Coefficient. Okay, then here order of the first third is 2, radicand is 2, order of the second third is 2, radicand is 2, order of the third third is 2 and radicand is 2. From all the three cases we can observe that the order and radicands are same. So this set of surds are numbers are nothing but what they are, like surds. So let me take
Like, sir.
next set of numbers, that is square root of 3, 5 square root of 3 and 4 square root of 3. What you can observe, what is the coefficient of the first third in this second example? What is the coefficient?
One, sir.
Very good, very good.
One,
If nothing
sir.
is there, one must be there. What we call it as the coefficient. What is the coefficient of the second third?
Five, sir.
Very good. What is the coefficient of the fourth?
Five.
Okay. Okay, okay. What is the coefficient of the third surd in the second example?
Four, sir.
Very good. What is the order of all those surds? What is the order? What is the
Three,
order?
sir.
Huh?
Three, sir.
Order. What? What is the order in
Two,
all?
sir. Two, sir.
Then you are still having confusion about the radicand and order. Order is above the square root. Within the square root is radicand. Okay. What is the radicand here?
Three, sir.
Very
Three,
good,
sir.
very good. When the order and radicand are same, those are called as like surds. Okay. I hope you are clear with the like surds, right? Okay,
Sir.
the next
Yes, sir.
topic that we are learning is unlike surds. What is the next thing?
Unlike.
Unlike surds. Okay, here in this case, if order, radicand, or both order and radicand are different, and radicand are different, then those are called as different or unlike surds. Okay, here point to consideration. I will explain you by using the example. The first thing is that here order are different. The second thing is it may have a radicand different. The third case is it may have both order and radicand are different. Try to understand that. Suppose if you have order different and radicand same, then it is unlike surd. If you have a radicand same and the order different, then it is unlike surds. If the order and radicand both are different, and then again they are unlike surds. First, let me take that if the order is different. So, just you observe the screen. That is here root of 2 is there, and 3 root of 2 is there. Whether order both in the both cases orders are same.
No, sir. No,
The
sir.
first third order is the first third order is
Two, sir.
and the
Two.
second third order is second case
Three,
order
sir.
is 3. Okay, here
Three, sir.
orders are different. The first third is having a 2 has order, and the second third is having a 3 has order, whereas the radicands are same. Can you observe the radicands are same or not? Yes or no?
Yes, sir.
So here,
Yes, sir.
even though you are having a radicand same, they are called as unlike surds. So let me take one more examples where you will have a radicand different, but the order is same. That is root of 2 and root of 3. Can you observe the orders are same in the both the cases? Order is 2 in the second
Yes, sir.
example. Here also order is 2. But radicand, what about the radicand? In the first case, radicand is somebody has on their microphone. Please off the microphone there. Okay, what is the radicand in the second example's first third?
Two, sir.
Very good. In the second case,
Two.
radicand is
Different.
second
Three.
case 3. Whether the radicands are same or different.
Different size.
Okay, then also those are called as unlike surds. And one more thing, suppose if you have a both order and radicands are different, again we are saying it has that is also nothing but unlike surds. Can you observe here what is the first square first order of the first third example's first surd?
Two, sir.
2.
Two,
What is the
sir.
order of the second surd? Order of
Three.
3. What about radicand? What about radicand of both the cases? 2 and 5. Whether they are different or
Five.
same. Whether they are different or same.
Different.
So what we can
Different.
take a conclusion? What we can take a conclusion is that these kinds of examples are being called as unlike surds. Okay, shall we take few examples? Still more example to clarify that which kinds of surds are called as like and unlike. Okay, shall we take now first example? Okay, root
Yes, sir.
3 and 2 root of 3 and 5 root of 3. Tell me whether it is a like or unlike.
Like, sir.
Why it is like surds? Anyone can give me an explanation for that? Why it is like surd?
Because order.
Order and see that
Order.
it should be very simple in saying because order and radicand are same. We never bother about the coefficient, right? So since the order and the radicands are same, they are called as like surds. Okay, now let me take one more example. That is root 3 and 2 root of 5 and 3 root of 6. Yes. whether they are like or unlike.
Unlike surds.
Why they are unlike surds? Why they are unlike surds?
Unlike surds.
The
Because
other crane.
order and order and
Very good, very good. Okay, okay. Here, cube root of 2 and cube root of 5 and cube root of 7. Whether they are like or unlike.
unlike surds.
Why the what is the reason behind to say that they are unlike? They are unlike. What is the reason? Because
Because radians are
radicands are different. What are different there? ಏನ್ different ಅದರಲ್ಲಿ?
indicated as difference in
Radicands are different, but what are same there? ಏನ್ ಸೇಮ್ ಅದರಲ್ಲಿ? Order is same. Okay, very good. Okay,
order
okay.
are same.
Orders are same, but radicands are different. Therefore, they are called as unlike surds. Okay, now let me take one more example. That is 3 root of 2 and 2 root of 2 and fourth root of 7. Yes, whether they are like or unlike.
Unlike
Why they are unlike? Why they are unlike? Why? Because their order and radicands both are different.
different sir.
Okay, shall we move to the next point now?
Different. Yes, sir.
Okay, here the next thing what we have to learn is operations of surds. What is the next thing you have to learn about?
Operation of surds.
Operation on surds. Operation is nothing but the fundamental operation, that is addition, subtraction,
Fraction,
multiplication, and
multiplication,
division.
division.
Okay, here uh, we are been learning about how to add and subtract the surds, how to multiply and divide the surds. So here we are going to start that operation on surds. The first thing is that here we are learning about the rule we have to follow, rule for adding and subtraction, add and subtraction of surds. What is the first thing we are learning now?
Add and subtract of surds.
So what is the rule we have to follow when we are adding or subtracting the surds?
Add and
Okay.
subtract of surds.
So the same rule is applying for the addition and subtraction. So the rule is that if we have to add and subtract the surds, the only one condition it has to satisfy, that it should be like surd. What it should be? Okay, keep that in a mind. Keep that in a mind. Already we have discussed what is meant by like surds. It means order and radicand must be same. Here, the first condition to add and subtract the surds is it should be a like surds, and the second thing is where we have to add. Which thing we have to add? Here, addition is done only for coefficient to coefficient. What to what?
Coefficient to
Coefficients. Okay, for example, here we are learning now that how to add. Okay, here we are going to start the first example. Suppose if you having a root 2 plus 2 root of 2, you can observe that they both are like surds. Yes or no? They both are like or not? Why? Because order and radicand are same. The first thing, that is like surds, has been satisfied. The second is addition should be done to the coefficient to coefficient. It means what is the coefficient of the first surd here?
3, sir.
First though.
Sir.
1. Where is 3 there? 1 is there. 1 to 1.
One.
Here means coefficient to coefficient we have to add. 1 plus what is the coefficient of second surd?
2, sir.
So 1 plus 2 is? 1 plus 2 is?
3, sir.
That is the result. What is the result? 3 root of 2 is the result. What is the result there?
3 root of 2.
Okay, let me take one more example now. 2 root of 3 plus 7 root of 3. Whether they are like or unlike.
Like, sir.
So, okay, first condition is satisfied. What is the second condition? If you have to add or subtract?
Add coefficient to coefficient.
Very good. So, what is the coefficient of the first surd? 2. 2 plus 7 is? 9 root 3 is your answer. Suppose 7 root 3 minus 2 root 3, whether they are like or unlike. Like, sir. 7 minus 2. What is 7 minus 2? 5 root of 3. Now, root 2 minus root 3. What is the result? What is the result? Root 2 minus root 3.
Root minus
Huh?
3.
What is the result of root 2 minus root 3?
Root minus 1.
Root minus 1. There you have been making the mistakes. Whether it is the first condition is satisfied to this case, whether the first condition is satisfied,
No, sir.
whether they both are like surds, then why you are saying that the root of something 1, you are saying the answer root of minus 1? Huh? So here they are not the like surds. We can't operate on them. Try to understand that. So the result is the same question, root 2 minus root 3. Yes, what is the result?
Root 3.
Why the same result we are getting? Anyone? Why we are getting the same result? Very good. Why? Because they are unlike surds. Okay. Shall we see still more examples? Okay. 3 root of 2 minus root 2. What is the result? Very good. 2 root of 2. Very good. Then root x minus root y. What is the result?
Root y.
The same thing you are going to get, or you are going to write root of xy. Whether you will write root of xy in this way. What will be the result? What will be the result?
Root x minus root y.
Very good. The same question will be repeated, root of x minus root y. Okay, is there any doubts up to the class what we have discussed today? Is there any doubts? Okay, can I ask few questions now?
Yes, sir.
Okay, what is surd? What is surd? Irrational root of a rational number. Very simple definition is there. What is surd? Okay, okay. What is the standard form of a surd? Standard form of a surd? Very good. N root of a. Very good, very good. What is that n represents there? What do we call for that n? Order. Very good. What we call for that a? A? Very good. Okay. Then tell me the statement that whether it is true or false that all surds are irrationals. True. True. Very good. All irrationals are surds. Why it is false? Why it is false? Okay. Then give the examples of surds to me now. Give the examples of surds.
Root 2, root 3, root 5,
Very good. Okay. Now, suppose if you have an example of cube root of 2. What is the example? Cube root of 2. What is the order there? 3 re. What is the radicand there? Very good. Okay. Then, what is meant by like surds? What is meant by like surds?
order and predicate are same.
Very good. What is meant by unlike surds?
If
Okay, I hope you have got the difference between like and unlike surds. Then tell me the rule we have to apply when we have to add or subtract the surds.
first rule is first rule is there should be a like
Very good.
and addition of
Okay. So usually children's what do they do that When we are asking them to add, they will add the radicand to radicand. Keep that in the mind. You should not add radicand to radicand. I hope you are getting my point.
Yes, sir.
Okay.
Yes, sir.
Then next rule will be coming. Next rule will be coming that you need to learn about the rule of multiplying the surds. What is that? Multiplying the surds.
Multiplying of the sir.
That the rule is different. Okay, we are going to see in the next class. Stick to those things which we have discussed today. Have thoroughly the comprehensions of all those aspects. If you are clear with these things, then you are able to understand or distinguish between the about multiplication of surds. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಹುಡುಗರ್ರಿ ಎಡಿಷನ್ ಮಾಡೋದ್ರೆ ಎಡಿಷನ್ ರೂಲ್ ಇದ್ದಲ್ಲೇ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ರೂಲ್ ಹಚ್ತಾರ, ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಇದ್ದಲ್ಲೇ ಸಬ್ಟ್ರಾಕ್ಷನ್ ರೂಲ್ ಹಚ್ತಾರ. There the both things are different. In the next class we are going to see that how we are the rule for multiplying the surds. Okay, I hope there is no doubts in the class today's.
Yes, sir. No, sir. Yes, sir.